why can't the streaming software memorize where I put this every time I restart? It has a settings button. It saves it. Why does it always lose track? Yeah. So, faster I get shit program done, faster I get back the JavaScript, and then I'll be able to like run Node.js in Vulkan, whatever, and then I can run my JavaScript engine in Vulkan, and it's like compared apples to apples or whatever. Otherwise, if you compare JavaScript in the browser, it's like, well, that's why it's faster, because the browser sucks. So if I have my own like Vulkan engine, I can compare like Node.js, because that is V8, to my engine, and it's like apples to apples, which is faster, which can like do more work between, I don't know, rendering or whatever. Well, also like if I like attach data to be rendered and it's going through the engine to like turn the logic in the output when it draws frames, whatever, then it's like comparing not just like the speed, but like how efficient it is or whatever. So I don't know. I get this stupid Vulkan API done. I'm gonna try to get like a little bit further. Not like 12 hours, I don't have much time, but a little bit further. I want to get to like output. Properties, whatever. I don't want to zoom out. It takes effort. Yeah. Yeah. Get something done. If I get it to log, and then store, and expand or whatever, the compressed data to the stages, and it's like, it prints, it looks like it's working, then it feels like, I don't know, then tomorrow, all stuff is like attaching everything to the current game loop or whatever, or like render loop, whatever you want to call it. Almost done. I need to focus. It'd be awesome if like stuff like just worked. That'd be cool. That'd be great. If like software like just simply worked, that'd be awesome.
The SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the MV of legacy octal escape sequence, the SV of non-octal decimal escape sequence, 8 is the string value consisting of the code unit 0x0038, digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0x0039, digit 9. The SV of hex escape sequence. X hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence. U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence. 0 is the string value consisting of the code unit 0x0000, null 1 2, 9, 4, 3 static semantics. MV, the MV of legacy octal escape sequence. 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence. 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence. 0 to 3 octal digit is 64, that is 82, times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit, the MV of 0 to 3. 0 is 0, the MV of 0 to 3. 1 is 1, the MV of 0 to 3. 2 is 2, the MV of 0 to 3. 3 is 3, the MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0x1000 the MV of the first hex digit plus 0x100 the MV of the second hex digit plus 0x10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2.2.2.1. An implementation may extend the ECMA script regular expression grammar defined in 2.2.2.1, but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminated but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminated but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars. Empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminated but not one of, all, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, B A C K S L A S H capital S E Q U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2. Each time the literal is evaluated. 2. Regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. See 2.2.4.34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify a part char. 2.9.5. 1. Static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body. 1.2.9.5. 2. Static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags. 1.2.9.6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template corrector sop. Template head. Template corrector sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template corrector sop. $. Template tail. Template corrector sop. Template characters. Template character. Template corrector sop. Note 2. Regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use comma dot. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. Sep. But only if MV of hex digits. 0x10ff. Code point. Hex digits. Sep. But only if MV of hex digits 0x10ff. Note template substitution tail is used by the input element template tail alternative lexical goal 1.2.9.6. 1. Static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the indexed components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code unit, S, of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters. Template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $, is the string value consisting of the code unit 0x0024, $. The TV of template character, template escape sequence is the SV of template escape sequence. The TV of template character, not escape sequence is undefined. The TV of template character, line terminator sequence is the TRV of line terminator sequence. 236. Copyright sign, ECMA International 2024, the TV of line continuation, Line terminator sequence is the empty string 1 2 9 6 2 static semantics. TRV, the syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $, is the empty string. The TRV of template middle, $, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting of the code unit 0x0024, $. The TRV of template character, template escape sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of template escape sequence. The TRV of template character, not escape sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of not escape sequence. The TRV of template escape sequence, 0 is the string value consisting of the code unit 0x0030, digit 0. The TRV of not escape sequence, 0 decimal digit is the string concatenation of the code unit 0x0030, digit 0, and the TRV of decimal digit. The TRV of not escape sequence, x, look ahead hex digit, is the string value consisting of the code unit 0x0078, Latin small letter x. The TRV of not escape sequence, x hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0078, Latin small letter x, and the TRV of hex digit. The TRV of not escape sequence, u, look ahead hex digit, look ahead, is the string value consisting of the code unit 0x0075, Latin small letter u. The TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, and the TRV of hex digit. The TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence, u, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, and the code unit 0x007b, left curly bracket. The TRV of not escape sequence, u, not code point, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, the code unit 0x007b, left curly bracket, and the TRV of not code point. The TRV of not escape sequence, u, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0x0075, Latin small letter u, the code unit 0x007b, left curly bracket, and the TRV of code point. The TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence, non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence, x hex digit is the string concatenation of the code unit 0x0078, Latin small letter x. The TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence, U hex 4 digits is the string concatenation of the code unit 0x0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence, U, code point, is the string concatenation of the code unit 0x0075, Latin small letter u, the code unit 0x007b, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit 0x007d, right curly bracket, the TRV of hex 4 digits, hexdigit 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 is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit, the TRV of hex digits. Hexdigits hexdigit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 A, B, C, D, E, F, A, B, C, D, E, F is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation, line terminator sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of line terminator sequence, the TRV of line terminator sequence, LF, is the string value consisting of the code unit 0x000A, line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0x000A, line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0x2028, line separator. The TRV of line terminator.
So boring.
The string value consisting of the code unit 0x2029, paragraph separator. The TRV of line terminator sequence, CRLF.
So boring.
The code unit 0x000A, line feed 2.10 automatic semicolon insertion. Most ECMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.1.0.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement. 1.4.7.2 When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to pass the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF, sequence. 38, ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the 2 semicolons in the header of a for statement. C14.7.4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. Plus left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue, no line terminator here. Label identifier yield await. Break statement, yield, await. Break, no line terminator here. Label identifier yield await. Return statement, yield, await. return, no line terminator here, expression, plus in yield await, throw statement, yield, await, throw, no line terminator here, expression, plus in yield await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await, arrow function, in, yield, await, arrow parameters yield await, no line terminator here, equals, concise body in, async function declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, yield, plus await, asyn, C function body, plus default, async, no line terminator here, function, formal parameters, yield, plus await, async function body, async function expression, async, no line terminator here, function binding identifier, yield, plus await, opt, formal parameters, yield, plus await, async function body, async method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, plus yield, plus await, async generator body, plus default, async, no line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async, no line terminator here, function binding identifier, plus yield, plus await, opt, formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, await, async, no line terminator here, async arrow binding identifier yield, no line terminator here, equals, async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, no line terminator here, equals, async concise body in, ECMA International 2024 239, async arrowhead, async, no line terminator here, arrow formal parameters, yield, plus await. The practical effect of these restricted productions is as follows. When a ++ token is encountered where the parser were treated as a postfix operator, and at least one line terminator occurred between the preceding token and the ++ token, then a semicolon is automatically inserted before the ++ token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter, s, are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is, a postfix ++ or operator should be on the same line as its operand, an expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the B, react, or continue token. The end of an arrow function's parameter, s, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2. 10. 2 examples of automatic semicolon insertion. This section is non-normative. The source, 12.3, is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source, 123, is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following. 1, 2, 3. Which is a valid DCMA? B. 40. Copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a statement. The source, return, A plus B, is transformed by automatic semicolon insertion into the following. Return, A plus B, the source, A equals B plus C, is transformed by automatic semicolon insertion into the following. A equals B plus C, the source. If B else C equals D is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement, the source, A equals B plus C, D plus C print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call, A equals B plus C, D plus E print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2, 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression A plus B is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus is not treated as a postfix operator applying to the variable B, because a line terminator occurs between B and plus. ECMA International 2024-241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2, 1, 0, 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tagged template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3. 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here, in this version of ECMA script. 2, 1, 0, 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions. 15.8, with relation to function definitions. 15.2, 42, ECMA International 2024, 13 ECMA script language, expressions. 3.1 identifier syntax, identifier reference, yield, await, identifier, yield, await, binding identifier, yield, await, identifier, yield await, label identifier, yield, await, identifier, yield, await, await, identifier, identifier name but not reserved word. 3, 1 static semantics, early errors, binding identifier, identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference, yield binding identifier, yield label identifier, yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference, await binding identifier, await bell identifier, await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier, yield, await, yield. It is a syntax error if this production has a yield parameter. Binding identifier, yield, await, await.
earlier, whatever. I need water. But like, as chatbot, like, what's like the web browser maker was using? Because I'm like out of the loop. And chatbot said, this thing called Webflow, whatever. It looks like they actually almost added 3D.
Scaling along the z-axis.
Wow. They got scaling in one axis. Whoa. A whole one axis. Oh my god. That's so impressive.
Lets us exaggerate the appearance of depth along the z-axis.
Oh my god, that's so amazing. Oh my god. That's
To demonstrate that, I'll select this card and add a transform.
oh my god, it's so exciting.
Under scale, we'll just adjust the value under z-axis and nothing happens.
Yeah, because it's one axis.
Which is exactly what is supposed to happen. What, Grimmer? Great question. Let me explain. Before anything can work, we actually need depth. So let's position these elements along the z-axis. But remember, in order to do non-isometric 3D stuff, we need to include... What?
Yeah, this is fucking lame. I mean, like... There's more than just one axis. There's like... There's X, Y, it's like X, Y, Z axes, not just one axis. It's like all three of them. So like I made this like website builder like 9 years ago, and 2026. I mean, like, I was years ahead of the time. I mean, the web browser had all this stuff for like so long. And like, they're just adding this shit, and it doesn't even work well. I swear, I must be retarded. I mean, like, I must be a complete idiot for like being able to like do something before it's cool. I must be an idiot. Man, I'm just so dumb. So you see how fast my JavaScript engine is? It's also years ahead of its time. Like, yeah.
You just wanted to say non-isometric.
That's what it is. Isometric doesn't distort them. Go into these transform options and add a children perspective, 1000 pixels. Look at the difference. Now that I've adjusted the distance here along the z-axis, I can select the parent element.
Oh my god, that's so lame.
In other words, with a card selected, let's now go in and adjust the z-scale, and voila! We can see that the depth of these elements is being exaggerated along the z-axis.
You can get the same exact effect with just zooming in and out. All he's doing is changing the distance between the things, its position.
What if we rotate this card? We can rotate our card on the y-axis and really see the effect z-scale has on our elements. We can see
Oh my god, it has all the axes. Whoa. Wow. It's so futuristic.
that depth in 3D space. That's how z-scale works. But what if we wanted to take this a step further?
Is there one more axis?
What if we wanted this effect to happen on hover? Well, with our card
Does only have two axes.
selected, we're in our non-state, but we'll do the hover later. Let's adjust our z-scale to a lower value that isn't 0. Because if we set it to 0, we break the laws of space and time.
Wow. That was funny.
Creating a virtual black hole that would take 1 second to
That's not
fix.
even science.
My computer is literally smoking.
No, that's Vanilla Bean from...
Let's start styling the hover state.
This is bad.
Rotation at the same time. Or add our own. Let's do 1000 milliseconds. And for extra drama, let's use an easing curve.
Ooh, berserkers.
Now, let's preview our work. And when we hover over our card, boom, we've just created an exploding
Man, I did this like 9 years ago.
card. And yes, the text is still selectable. But that's you.
How are people just doing it? When was this released? Like 5 years ago? I don't know, I guess it does have 3D. At least it's not just one axis. That'd be pretty sad. Oh wait, does he have like an interactive HTML what do you call it? Like node system or something? You know, I don't care. Man, the input is not working like it used to. Where the heck did it go? Oh, position absolute. So like 25, 25. Get it centered. Wait, that's not centered. Oh, thirds. No, wait. Man. Wait, that is centered. If it's 25% width and 25% from side, it should be 50% wide. Oh my god, I gotta like figure all this stuff out again. Wait, is that centered? How is that the center? Oh, I picked the wrong one again. Huh. Oh, it's because it has height. Why is the box outside? Oh, it's in pixels. Duh. Oh no, it makes sense. So 33, 33, 33. It's 99. So like at thirds, that's what, 33.3? Oh, that's annoying. Man, I hate web design is stupid. Hooray, it's centered. Or I could have made a box that's like 50%. An offset box instead of that 50%, like negative 50%. That probably would have been better. That'll take 2 boxes though. So I don't know, whatever. Oh, this isn't fun. I should probably like plan out a website and then make stuff. Yeah. I'll just get back to programming. I need more caffeine. Web design is like the worst. I bet there's like a lot of people that like figure this out also. I doubt. Well, that website has menus. I don't know. Making menus and stuff is like next level. And anybody else that like realized the browser is 3D and thought, oh, I'm gonna make something. They probably did make something. And then they're like, oh, fuck. People just like steal my shit. It's not worth it. And then like, nobody has 3D websites. Because people can just like steal your shit. That's web design. Web design sucks. It's literally like the definition of like not fair bullshit. I don't know. It's not possible to make something on the browser unless it's server side without being stolen. So it ruins it for everyone else. Everything is like so stupid. I'm gonna try like get this shit logging. And yeah. I got like stuff to figure out. I cannot focus. I gotta replace this website at some point. This is ugly. It's an ugly website. It's not even 3D. It doesn't even like move with the mouse. I hope that doesn't actually send emails to me. I should double check that. Why do they give you like a broken placeholder website? oh, they probably want like, if it gets traffic or something, then they'd say, oh, we're gonna charge you like $20. You're like, what? Like, oh, we gave you a default website. You didn't know? Oh, well, it's $20. Stupid. I think I remember finding the website a couple months ago. It was like, I don't know, not memorable. So I forgot. This is done. there's like another array inside the array of the array. There's so many. Oh my god. I need another loop. Seriously. I need another loop. And then I need a loop inside of that loop. And then I can get the data. My god. It's like 5 loops. Holy fuck. This fucking sucks. Oh my god. So I need to like access this thing, get the length, make one more loop for this thing. That's here. And then access this. And then get these. And then print them. And then save them. Well, not individually, like set the pointer to, I guess here, for each of stages. And then whatever makes up the monkey vertexes, it's layout set, bind add, bind descriptor array length, and then typing them. Oh man, this is so annoying. So whatever properties for whatever array, for whatever part that makes up the piece of this monkey. When I actually edit this is a Blender, I like export it. Should work. There's one thing I gotta do maybe. I don't want to do it. I'd have to make like another stupid macro file that includes itself, like count, and like assign a constant number or whatever. Otherwise I'd have to manually tag them one by one. Or if it's a constant, I can like bake it in. If it's like a normal var, or not constant, a literal. If it's like constant, not literal, then I'm stuck with like having to waste a freaking access to get it. I gotta think. I got where's your tag? The work it would take to add one more property. Man. I'm gonna just have to make it work. I'm not going through that. And yeah, I'm done with this for now. I gotta like think ahead a bit. I had to like backtrack so much last week. It was so frustrating. Oh. finish this up tomorrow. I might actually be able to get like all once done. So, pick up on this tomorrow. Peace. I should just end this super early.